complex circuits. In the previous video we did simple circuits, meaning that they were either series or parallel. Now they're kind of both. Would you call this a series circuit or a parallel circuit? Well, the 12-volt battery, I'd say, is wired in series with the 2-ohm resistor. Okay, there's that. But the 4-ohm resistor is wired in parallel with the 6-ohm resistor. So is it a series circuit or a parallel circuit, or both? It's complex. Complex versus simple is not the same thing as difficult versus easy. Things can be simple and very difficult at the same time. They can be complex and easy at the same time. I hope this will be easy eventually. Then it will be after you do 100 of them. So let's get to work analyzing this circuit like we analyze those other circuits. And the first step is to turn this complex circuit into a more simple circuit by looking at these two resistors and trying to find the equivalent resistance. All right, we can do this with an equation. 1 over 4 plus 1 over 6. So that's 3/12 plus 2/12 is 5/12. 12 over 5 is 2.4. 2.4 ohms. That is the equivalent resistance of those two resistors. You could take out those two resistors and put in a 2.4 ohm resistor, and the battery would not know the difference. Batteries can be easily fooled. Anyway, let's now, hey look, a series circuit. I know how to do this. Let's find the total resistance. Total resistance, 2 plus 2.4 is 4.4. That's good. We can make it a little bit more honest now, and we can move on to the next step. The next step, V equals IR. 12 divided by 4.4 gives a total current through the battery of 2.7 amps. 2.7 amps. Now, not everybody gets the 2.7 amps. The 4-ohm resistor can't get the full 2.7 amps because then the 6-ohm resistor wouldn't have any. But one bulb does get the full 2.7 amps, and that is, of course, bulb 3, which is the 2-ohm bulb. Why does it? Because, like I said, it's wired in series with the battery, and being wired in series means you have the same current. You have to, otherwise you're creating or destroying charges, and we don't do that sort of thing. All right, next step. V equals IR. 2 times 2.7 gives us 5.5. You'll have to forgive the rounding here. I'm limited in space, but I have 5.5. That's the voltage drop across the 2-ohm bulb. And here's the deal. I got an allowance of 12 volts, a $12 allowance. I'm spending 5.5 volts or $5.50 at that first store. Now, I haven't decided yet whether I'm going to go uptown to the 4-ohm store or downtown to the 6-ohm store. I'm going to go to one or the other, but no matter where I go, I will have $6.50 to spend. Where did that 6.5 volts come from? Well, 12 volts minus 5.5 volts gives you 6.5 volts. And that's where that came from. Or look at it this way. I took those guys out and replaced them with a 2.4 ohm resistor. You follow this? 2.7 amps times 2.4 ohms gives 6.5 volts. Yikes. But there it is, and we're rolling, and V equals IR gives us the current through the 4-ohm resistor and the current through the 6-ohm resistor, and those are nice. Those are nice for a couple of different reasons. Number one, we expected the 4-ohm resistor to get a little bit more current. It's got a little bit less of a resistance, so a little bit more current there. That's good, but we're really happy that 1.6 plus 1.1 equals 2.7 amps. 2.7 amps, 27 electrons march bravely into that juncture. 16 go north, 11 go south. They meet up together and nobody got lost. Here we have P equals IV, power, and there we have some powers, and we can see in this configuration that the 2-ohm bulb was the brightest, in case anybody cared. All right, we're going to take that same 12-volt battery and these 3 resistors, and we're going to scramble them up into one final circuit. This is our last circuit, so let's make it a good one. Again, it's complex. It's complex because we got some parts in series. I'd say that 4-ohm resistor and the 2-ohm resistor are wired together in series. Anybody going through the 2-ohm resistor gonna have to also go through the 4-ohm resistor. No choice. But the circuit overall does also allow multiple paths. So let's take a look at it, starting with these two guys, and find the equivalent resistance of those two resistors. I can do this in my head. 4 plus 2 is 6 ohms. So again, we'll take those two resistors out and substitute in a 6 ohm resistor, and the battery won't be able to tell the difference. Now we have a parallel circuit. Let's find the total resistance. I know this is a little bit different than how we did it before. Let's find the total. We can do this. 1 over RT is equal to 1 over 6 plus 1 over 6. So 1 over RT is equal to 2 over 6. So RT has to be 3 ohms. 3 ohms, the total resistance of that circuit. Let's make it a little bit more honest. And we can find the current. The total current through the battery is 4 amps. Now, who gets that full 4 amps? And the answer is the battery and nobody else. Those 4 amps split up before they get through any of those resistors. So we're going to have to find, but we're talking about parallel here, kind of parallel. So we can find voltage. It doesn't get the full 4 amps, but that 6 ohm bulb gets the full 12 volts. Again, let's think about your allowance. You got a $12 allowance. See, I would use the paycheck, but talking about a $12 paycheck just doesn't make a lot of sense. Anyway, you get $12, and you got a choice. Are you going to go to that 6 ohm store and spend all your $12 at Starbucks? Or are you going to go to 2 different stores and spend $2 on gum and $4 on something else? You got a choice. But if you go to the 6 ohm store, that's your only stop. You spend your full 12 volts there. Strained analogies, I admit it, but the equation V equals IR is still good. 12 divided by 6, that's 2 amps. We have 4 amps out of the battery, 2 amps going through that middle path. And if you have 4 amps out of the battery and 2 amps going through the middle path, how many amps, how much current is left? That's right, 2 amps go through the top path also. Or you could look at it again, you could look at it like this. You got a 12 volt battery through a 6 ohm equivalent resistance up top. 12 divided by 6 gives you those 2 amps. 2 plus 2 is equal to 4. We're happy. And again, when I say 2 plus 2, I'm talking about the 2 amps through the 6 ohm resistor and the 2 amps through the entire top branch. A lot of 2's to talk about. Anyway, let's talk about the voltage drop. V equals IR again. 2 times 2 is 4 volts. 2 times 4 is 8 volts. And those voltages make us happy. Once again, you start with 12 volts. You're going to the top branch. You go through the 2 ohm resistor and spend 4 volts there. Then you go through the 4 ohm resistor and the voltage drop is 8 volts there. And you're done, except for power. And P equals IV. And in this case, who's the brightest bulb? This time, it's the 6 ohm bulb that's brightest. And yes, that was a lot. But where did it come from? Just these 2 simple, and when I say simple, I don't mean easy, just these 2 non-complicated equations. I mean, as far as equations go, you can't get much shorter than that. So just these 2 equations and these rules. Think about them. Conservation of energy, conservation of charge. Which even kind of makes some sense, I guess, depending on who you ask.